Let's move on to our next speaker from Edgar L to talk to us about science backroom training for lunar exploration, learning from analog training in northern Arizona.
Great, thank you. Feel free to advance to the title slide there. This is our standard government disclaimer. Hi, I'm Lauren Edgar, and today I'll be talking about science backroom training for lunar exploration with a focus on analog training in northern Arizona at sites such as the widely used SP Crater and lava flow training site that are shown here on the title slide. And this talk is hopefully going to address some of the guiding workshop questions related to what lessons can we leverage from Apollo on ideal training activities or strategies for crew and science team, and what are some of the best ways to integrate engineering, mission operations, and science in the run-up to the mission. If you go on to the next slide. The preceding talks have done an excellent job of emphasizing the point that integrating science into mission preparation is critical to mission success. I've taken a few key points from your abstracts, which were discussed in more detail in the earlier talks. But earlier this morning, we heard from Jack Schmidt that the science support room, staffed by field geologists and other scientists, experienced astronauts, and relevant engineers, can greatly enhance the scientific return. And that regarding Artemis, each crew should have training and field experience at least to the extent of the Apollo 15 to 17 crews, if not more. Then Feist et al. Noted that for Artemis, adding a new flight control position, the exploration science officer, would enable more direct contact between the MCC and geology backroom support activities. And then recently from Heldman et al., noting that a transdisciplinary collaborative environment is essential for the optimal scientific return for Artemis. So it's not whether science should be a driver, it should. The question is how the mission team can effectively be trained in the scientific parameter space, and what role does training have in mission preparation, execution, and success. If you go on to the next slide. So in this talk, I have two objectives. First, I'll review the involvement of scientists in field training during Apollo, and here I'll be focusing on how the geology of northern Arizona contributed to science training and planning for Apollo. And then I'll discuss current capabilities to support science training in northern Arizona and how and why this region could play a similar role in geologic training and planning in advance of Artemis. If you go on to the next slide. So this reviews some of the Apollo field training for astronauts, which covered a wide range of topics, everything from geologic principles and processes to field methods, equipment, and operations. And this training was co-conducted by NASA and the USGS, with NASA using the Manned Spacecraft Center and USGS using the actual field. Despite this initial rocky start with the dual location, ultimately the dual location and institutional collaboration was hailed by crew. If you go on to the next slide. So this shows some of the key training locations in northern Arizona. So field training for Apollo occurred in a number of different analog locations, including Texas, New Mexico, Nevada, Hawaii, Iceland, and so forth. But here we're focusing on activity in northern Arizona due to the wide range of planetary analogs that are in close proximity and the essential role that it played in Apollo training. So what we're looking at, Flagstaff is there in the middle of the broader San Francisco volcanic field. We have some widely used sites, and many of you are familiar with SP Crater, Sunset Crater, the Cinder Lake Crater Field for training, as well as Black Point Lava Flow, which was used extensively for the Desert Rats exercises. We also have Lava River Cave, which is a kilometer-long lava tube off on the west side there. And as you move to the east, you get into the Hopi Buttes volcanic field, which allows for a comparative volcanic environment with a lot of Mart and diatreme volcanoes in that field. And then, of course, we have Meteor Crater. We have Verde Valley to the south with a interbedded sedimentary and volcanic sequence, and the Grand Canyon to the north. And I just want to point out that these sites are logistically accessible and repeatable, which allows for recurring visits and comparative environments, which is why it became such a key location for Apollo field training. You go on to the next slide. So one of the key lessons from Apollo is that scientists became integrated in all aspects of field training and simulations. So here we're looking at the involvement of scientists in field training in helping to conduct the teaching of field geology and mapping, but then also working through localization and traverse planning, the prioritization of science observations, working through how sample collection and tracking would work, the development of hand tools and instrumentation, as well as anomaly response and communication. And if you go on to the next slide. So some of the lessons learned from Apollo is that field training is essential. I'm glad that everyone is in agreement on that from what we've heard so far. And that planning for human exploration missions requires frequent interaction between scientists, engineers, traverse planners, site selection representatives, equipment personnel, astronaut trainers, flight controllers, and astronauts. And the simulation should be as realistic as possible and should replicate the communications, personnel, procedures, and traverses that will occur in the planned missions and should involve all of the relevant personnel that I just mentioned. And that really noting that scientists should be integrated throughout the entire process. We've heard over and over again that the success of Artemis will rely on well-trained crews and well-trained scientists as well. You go on to the next slide. Obviously, there are some key differences between Apollo and Artemis, as many of these other workshops have noted, but I mentioned these couple in the context of training considerations. First, with Artemis going to a high-latitude landing site, future training sites should consider high-latitude terrestrial analogs or the simulation of such conditions. And then second, that technology has obviously advanced dramatically since Apollo, and that field tests continue to be the most robust way to find the optimal use for capabilities, such as field portable instrumentation, human-robot partnerships on the lunar surface, virtual reality in the science back room, as well as for astronaut training, as well as the whole data integration pipeline and informatics. And then also with the goal to create a sustained human presence on the moon, this raises the importance of volatiles and in situ resource utilization in training considerations. And so obviously the range of field sites that will be used for Artemis will need to be adjusted to address mission-specific goals. So just noting that we are aware of that. But if you go on to the next slide. There we go. For the last few slides, I just wanted to discuss some of the advantages and current capabilities for training in northern Arizona. As previously noted, obviously the historical use of this region as a training site with some well-established field areas. We have local government and land use ties, as well as access to a range of geologic and morphologic analogs that provide some easy logistical access for training and testing. So really on this point of the fact that these are well established and logistically easy is something that's important to keep in mind when we're operating on a condensed timeline for Artemis, having these well established locations that allow for repeatability. That repeatability to visit a field area is also really important for integrating science and technology considerations. And then furthermore, these immersive environments for collaborative learning, you can have scientists, engineers, managers, folks that are working on tools, informatics, all together in some of these close proximity locations. As well as having a dedicated location and personnel to test procedures and tools as needed, including the ability to support remote operations. And also wanted to point out the proximity to geologists, data scientists, and software engineers, and the proximity to the USGS to be used as a staging area if needed. You go on to the next slide. So as part of that, I just want to make the community aware of some of the products and services that the USGS can provide as part of the TARGET program, which stands for Terrestrial Analogs for Research and Geologic Exploration Training. This was established to respond to community needs, and there's really 4 key components of training, research, sample collections, and data archiving. Through this program, we've been developing training resources and field guides for some of these widely used analog locations that were noted on the previous slides. We've also been helping to facilitate research and training trips and helping to develop science-based decision-making for traverse planning, as well as building a data portal to facilitate access to existing field data and archive new field data. And then also we have some ongoing curation of analog sample collections. So I just wanted to mention these to make the community aware of these efforts and how they might pertain to training for scientists, engineers, mission teams, and crew. And then if you go on to the next slide, speaking of the field training facilitation, these capabilities have been used in recent years in coordination with JSC, Goddard, and academic partners to facilitate NASA engineer and manager training, as well as astronaut training. And the USGS has also been involved in support of science backroom activities at nearby analog locations as part of the NASA Desert Rats exercises, as well as helping to conduct geologic mapping exercises for these groups, mission teams, and others. I just wanted to note that the current training efforts at these nearby locations can also be expanded to include science backroom training or whatever science center training you want to call that for Artemis, and facility support via existing resources at the USGS. And if you go on to the last slide, Just wanted to note that Apollo demonstrated the importance of involving scientists at all stages of crewed operations and the integration of scientists, engineers, managers, astronauts, and others in field simulations, and that science backroom training to support the Artemis program would benefit from a similar approach. There are many lunar analog training grounds found here in northern Arizona, and the USGS is prepared to support these here or elsewhere. And in addition to field training opportunities in response to community needs. So with that, I will turn it over to questions and look forward to further discussion in the breakouts.
Thank you, Lauren.